Hello dear viewers, today we are going to implement the ASA basic settings using ASDM in GNS3. This lab is from CCNA Security 260-210, Chapter 10, Lab A. So the topology for this lab is shown here. So it needs 3 routers, 1 ASA, 3 switches and 3 host machines. So the ASA will be the central focus here. It will have the outside zone, the DMZ zone and the inside zone. For the outside zone, we are going to use the network 209.165.200.224/29 network. So that 226 will be on the ASA side and that 225 will be on the router side. And then the inside interface will be on the E01 interface. 192.168.1.0/24 network will be used. And for the DMZ zone, 192.168.20/24 network will be used. So today we are going to implement this topology in GNS3. So to implement it in GNS3, we are going to do few changes. So the original lab, the CCNA Network Academy, requires the use of ASA 5505. Unfortunately, this 5505 ASA is no longer recommended by CISCO. So to implement this in GNS3, I used ASAv. It's a virtual ASA. So the difference is, if we are using 5505, we rely on VLANs. Since 5505 is a layer 2 device, we have to set up VLANs to separate the 3 zones, outside, the DMZ and the internal zones. But here in ASAv, there is no need to create VLANs. So each interface will have its own separate network. Because of that, there is no need to set up VLANs here. So this is what we are going to implement. So as you can see, we have the 3 routers. Okay, router 1, router 2 and router 3. Between router 1 and router 2, we are going to use the 10.1.1.0/30 network. Between router 2 and router 3, 10.2.20/30 will be used. Between the ASA and R1, we are going to use 209.165.200.224/29 network. The DMZ zone will have 192.168.2.0/24. The inside zone will have 192.168.10/24. And the outside zone will have 172.16.30. And we will connect 3 host computers. Okay, PCA will be the host computer in the DMZ zone. So we are going to consider this as a DMZ server. Okay, and then we will have PCB, which is connected to the inside zone. This is the internal computer. And PCC will be the outside host, which is connected to the outside zone. PCA and PCC will be virtual machines. So we are going to use Windows 8 and Windows 10 virtual machines here. Whereas PCB will be the actual physical machine. So I'm going to connect the G01 interface of the ASA directly to the physical machine using Microsoft Loopback adapter. So this is the configuration we are going to implement. And the tasks we need to accomplish in this lab will be: part 1, we are going to do the basic device configuration. So we are going to do the cabling. Okay, in case there is any previous device setting, we are going to clear that. Okay, and then put the IP settings for each router and switch and the host computers. And we will enable HTTP server on R1 and enable V2I line passwords. And finally, we will verify connectivity between routers. Okay, so this will be part 1. In the second part, we are going to access the ASA console and set up ASDM. So we are going to access the ASA and clear any previous setting. We will bypass any setup mode and configure the ASDM, and then we will configure the ASDM, verify access to the ASA, and finally we are going to explore the graphical user interface on the ASDM and check some of the functionalities available for us. And in this part we are going to test connectivity to the ASA by pinging from the internal computer. Okay, in part 3 we are going to configure our ASA settings and firewalls using the ASDM startup wizard. So we are going to configure our ASA by using startup wizard. We will configure host name, domain name, enable password, configure the inside and outside interfaces. And then we will configure the DHCP server, address translation, and administrative access to the ASA. And then we will review the summary and deliver the commands to the ASA. Test access to an external website from the PCB. And then we will test access to the external website using ASDM packet tracer utility. So this is part 3. In part 4, we are going to configure the ASA settings from ASDM configuration menu. We will set up date and time. We will configure static route, configure AAA user authentication, and create user name. We will test SSH access to the ASA. We will test connectivity using the ASDM ping and traceroute commands. And then finally we will modify the MPF application inspection policy so that we are going to allow ISMP packets. This will be part 4. And the final part will be to configure DMZ, static network address translation, and writing ACL so that we will allow specific traffic through the ASA. Because by default the ASA is configured to block any traffic from lower security level to higher security level. So because of that, any traffic which comes from the outside will be blocked. So there are some traffic we may allow from the DMZ to the internal zone or from the outside to the DMZ. So by writing specific ASLs, we will be able to accommodate that. So these are the 5 parts we are going to accomplish in this GNS3 lab. Now, without further ado, let's move to the GNS3 settings. Now I have opened GNS3 and let's configure our topology first. So our topology requires 3 routers, so I'm going to use a 3725 router. So I will put 3 3725 routers. So R1, R2, and R3. Okay. And then I will have the ASA. I will have the ASA. And then I will have 3 Ethernet switches. So I'm going to run the switches in the GNS3 server. Switch 2, again I will run it in the GNS3 server. And then switch 3. And then I'm going to put host computers. I'm going to put a Windows 10 machine for the external network, Windows 8 machine in the DMZ zone, And then I'm going to bring cloud. I will run the cloud in the desktop. Okay. Now we have all the connections we need. I'm going to rename the ASA as CCNAS-ASA. This is switch 1, S1, S2, and S3. This Windows 8 machine is PCA, so I'm going to name it as PC-A, and its IP address will be 192.168.2.3. Now this cloud connection, we are going to use it as PCB, and PCB will have an IP address of 192.168.1.3. This is the external PC. We are going to call it PC-C, and its IP address is 172.16.3.3. These are the IP addresses for the host machines that we are going to assign. Now let's do the wiring. So we are going to click on the add link. And then from router 1, serial 00 to router 2, serial 00. From router 2, serial 01 to router 3, serial 01. So these are the point-to-point links we need between routers. Okay. Now, from G00 interface of the ASA, we are going to connect to fast Ethernet 00 port of the router. Okay. And from G02 interface to switch 1, and from switch 1 any port can be used here. We are going to connect it to Ethernet 0 of the Windows 8 virtual machine. From G01 interface of the ASA we will connect to switch, and from switch port we are going to connect to Ethernet 2 here. So these are the interfaces we have on my physical computer. I am going to show you here. Change adapter settings. So I have 3 adapters here: Ethernet, Ethernet 2, and Ethernet 3. Ethernet 3 and Ethernet are physical adapters. I'm connected to Internet using the Ethernet 3 adapter, but I have also created another adapter here. This is a Microsoft loopback interface, so I'm going to use this loopback interface to connect to my physical machine. So Ethernet 2 will be used. Now this now is PCB. Okay. Now for simplicity, I'm going to change this cloud image now. So right click here, change symbol, and you can change it to whichever symbol you want to use. For now I'll change it to computer. Now it looks like a physical computer, but we know that this is connected to my physical computer through a loopback adapter. So this is what we have. Now on the router 3, F00 port will be connected to switch, and switch will be connected to the virtual machine. Okay, Now physical wiring is done. Now what is left is to label each of the interface. Okay, so I'm going to use a add node here, and this side here from G00 interface of the ASA to R1 is 209.165.200.224/29 network, so that G00 will be using that 226 and F00 of the router will be using that 225. So this will be what we are going to use. Okay. And then we have the G02 interface here. From G02 interface to switch 1 is our DMZ zone. And this zone is going to use 192.168.2.0/24 network. And that 1 will be used on the G02 interface. And that 3 will be used for the Windows 8 virtual machine. Okay? And the G01 interface is our internal zone or inside zone. 192.168.1.0/24 will be used for this zone, and the G01 interface will have the first IP address. Between router 1 and router 2 we have a point-to-point link, so we are going to use 10.1.1.0/30 network, so that one, the first IP will be used for R1, and the second IP will be used for R2. Between router 2 and router 3 we are going to use 10.2.2.0/24/30 network, and .1 will be used here, .2 will be used here, and .1 will be used on the R3 side. Here we have the outside zone, and this zone is going to use 172.16.3.0/24 network, and that 1 will be used for F00, and that 3 will be used for the Windows 10 virtual machine. So these are the IP settings we are going to use. Okay, so now the IP settings are fine. It is now time to check connectivity and put the IP addresses for the Windows 8 and Windows 10 and the actual physical machine IP address. Now let's start each node. Okay. Now all the nodes are being started. As you can see, the Windows 8 and Windows 10 machines are now booting up. Let's wait until they boot up. Okay. While they are booting, let's check the available interfaces for the Windows 8 and Windows 10 PCs. Right click on the Windows 8 PC, click Configure and click Network, and on the interface type we have the option to use either VMNet 2 or VMNet 3. So for Windows 8 let's use VMNet 2. Click OK. And for Windows 10 let's use VMNet 3. Okay, Windows 8 VMNet 2. So let me write it. Here we are going to use VMNet 2, and here we are going to use VMNet 3. So these are what we are going to use. Okay, now we have this topology. Once we have this, let's check on the machines. The Windows 8 machine is up. As I have mentioned, the Windows 8 machine is going to use VMNet 2. Okay, so if we look at here, it is indeed using VMNet 2. Okay, now click on desktop and look at the IP setting on the adapter. Change adapter settings, double click on the Ethernet 2 properties, and on the IPv4 setting use IP 192.168.2.3. Mask will be 255.255.255.0 and default gateway. 68.2.1 will be the default gateway here, and click OK and close this and close. So now we have applied the IP settings on the Windows 8 machine, and the next thing we want to do is we are going to turn off the firewall. Okay, we are going to turn off the firewall. So I'm going to open the control panel. Okay, I will change the view and look for Windows Firewall. Turn on or off Windows Firewall and make sure Firewall is turned off and click OK. And exit out of this and check the Windows 10 machine. And Windows 10 machine should use VMNet 3. As you can see, we are using VMNet 3. And now let's change the IP setting. Change adapter settings, double click it, properties, TCP IP v4, use 192.172. That's 16.3.3, 255.255.0, 172.16.3 properties, PV4, use 172.16.3 255.255.0, 172.16.3.1. So we are going to remove the IP from the absent adapter and click OK. So if you look at the properties, we have the IP set up properly. So now the IP setting for each device is done. Now for this Windows 10 machine, we are going to disable the firewall. Yep, it is already turned off. Click OK and exit out of this. So now the IP settings for the Windows 8 and Windows 10 machine are set. Now we are going to set the IP address on the loopback adapter. So I'm going to get into the network and adapter settings, click on change adapter settings. I have the Ethernet 2 as loopback adapter, double click, properties, IPv4. So the IP is already set up, 192.168.1.3, 255.255.255.0, and default gateway 192.168.1.1. So the IP is configured. Click yes and close out of this and close. Okay, so all the three PCs here have the required IP address. Now let's configure the basic IP settings for R1, R2, R3 and the ASA. Now if you remember from the initial diagram we have seen, we have each IP address to assign, and this IP address now will be configured on the device. So in order to facilitate our configuration, I have already made a template for each router. So we will use these templates as is. Okay, now let's start from R1. I'm going to double click R1 so that we will enter into the CLI. So now I am into the CLI of the router. Okay, now I will bring my template. No IP domain lookup, so that in case we have wrongly entered commands, they will not be resolved. For DNS resolution, hostname is changed to R1, serial 00 port will have clock 64 kilobit per second. Since serial 00 is the DCE side, we are assigning a clock rate, and then its IP address is assigned, no shot. F00 port will have IP address 209.165.225. Okay, and then we are going to assign a static route for R1. Okay, any unknown destination reaching R1 will be forwarded to the 10.1.1.2 next hop address. Okay, and then we are going to have a minimum password length requirement of 10, and then we have a secret password. We have created a username. The domain name is CCNA Security.com, and then we are going to encrypt any password we are going to use for console and VTY lines. Okay, the line console 0 login is local, so that we will authenticate ourselves through the local database. Logging synchronous, and then for the VTY line we do the same, but we are going to enable SSH so that we have security enforced. and then we have a banner message, unauthorized access, strictly prohibited, and then on R1 we enable HTTP server, okay, and authentication will be local, and then we generate a 1024-bit RSA key. So this is the configuration for router 1. So you can pause the video and copy this configuration to R1. For now I'm going to copy this configuration, copy, and I will paste it into R1, and make sure you review the CLI for any error message. So I don't see any error message, so that looks good, and let's save the configuration now. So I just saved the configuration for router 1. Now we are going to proceed to router 2. Double click R2, R3, ASA. Okay, so now we are going to click on R2. So router 2 is up. Now for router 2 our configuration will be here. So again, you can pause the video and copy the codes for R2. So let me minimize the font a little bit so that we can see everything. 14. Okay. So the router 2 configuration will have a loopback interface also. I'm going to reduce the size one more. 12. Okay. So these are the configurations we are going to use. Okay. So for router 2 we do the same thing, except that the static route we are going to define is now 2 static routes for router 2. So our static route will be, for this router we have to tell about this network. To reach this network they are going to use 10.1.1.1 next hop address or serial 00 exit interface. And to reach to the 172.16.3.0 network, router 2 is going to use the 10.2.2.1 next hop address or the serial 01 exit interface. So these 2 static routes must be defined on router 2. So that's what we have done in this static route. Okay? So this is what we have on router 2, and we are going to copy this. Copy and paste it to router 2. Okay? On router 2, right click and make sure there is no error. As you can see, I don't see any error, so that's a good sign, and save the configuration. So router 2 configuration is now done. Now let's move on to router 3. So for router 3, these are the configurations we are going to put. Okay. Security, password, minimum length requirement is fixed. Host name is changed to R3. Again, the VTY lines, the console line are done. Username was defined as admin01 with privilege 15 and secret admin 01 pass. And then we have a static default route here. If there is any unknown destination reaching to the third router, it is going to send it to 10.2.2.2 next hop address. So I'm going to copy this now and paste it to router 3. So go ahead and copy it and review. As you can see, there is no error. Okay, hit enter and save the configuration. Okay, now router 1, router 2 and router 3 configurations are fine. Now let's check if this is indeed true. So now what we are going to do is we are going to ping from the F00 interface from router 1 to router 3 interface and see if this is indeed true. So on router 1, I'm going to send a ping request. Ping 10.1.1.2. I'm just pinging the next address. That looks fine. Ping 10.2.2.2. It looks fine. Ping 10.2.2.1. It looks fine. Ping 172.16.3.1. And that looks fine. Okay. Now let's see if we can ping the host on the external network. Ping 172.16.3.3. Yes, there is one packet dropped because of the ARP request. Other than that, it is successful. It looks like the static route we have defined is working fine. Okay, so by this we have completed the first task. If we look at the first task, do the cabling, configure the basic router and switch settings, and then configure the static route, including the default routes between R1 and R2 and R3. We have enabled HTTP server on R1, and we have set the VTY lines. We have configured the PC IP settings, and we verified connectivity, and it worked fine. So these connections are now done. So part 1 is completed. Now our next task will be part 2. We are going to access the ASA through console and set up the internal interface, enable HTTP so that we will be able to set up ASDM. That will be our next task. Let's move on. So we are going to open the ASA console. So our ASA is ready, enable. So there is no password initially, so hit enter. Config T. Now I'm going to open the int G01. I open the G01 interface. IP address 192.168.1.1. 255, 255, 255, 0. Name if, and name of the interface will be inside, and by default the inside interface will have a security level of 100 and no chat. Okay, so now we have assigned the IP address to the G01 interface of the ASA. We can also set up the other interfaces here, or we can do it from the ASDM. Let's do one of the interfaces here, and then we will do the remaining interface in ASDM. Let's do the DMZ interface now. And G02 IP address 192.168.2.1 255 255 255 0. Name if DMZ and security level. Let's assign a security level of 70 for the DMZ and no chat. So our DMZ now has a security level of 70, and we can also create our outside interface int G00 IP address 209.165.200.226 255 255 255 248. Okay, name if outside and no chat. Exit. Now we have created the 3 interface. Now let's do HTTP server enable. Okay, and we are going to allow the internal networks to have HTTP access for now. HTTP 192.168.1.0 255 255 255 0 inside. So the inside network will have access. And now let's save our configuration. So this is the initial configuration we need for the ASA. I also have the template for this, so that you will be able to initially have the configurations. So we are going to set up the domain later. For now, our interest is to assign the internal interface, the outside interface, and the DMZ interface, and then make sure HTTP is enabled. Okay, so these are the initial configurations we need for now. All the remaining configurations we are going to do it from the ASDM. So this configuration is what we are going to use to initially set up the ASDM access. Now let's see if we have connectivity. Okay, I'm going to open command prompt in the internal zone. So our internal zone is the actual PCB. So I will open command prompt and ping 192.168.1.1. And as you can see, we have a successful ping. This shows that our connection to the ASA is working fine. Okay. Now let's see if we can access the ASDM. Now to test for the ASDM, we are going to open a web browser. Okay, I'm going to open Chrome. And type https 192.168.1.1 and hit enter. And initially you will see not secure, so click on advanced. And proceed to 192.168.1.1. And you can install the ASDM launcher. In my case, I have already installed it, so we will open the Cisco ASDM directly. So I have already installed the launcher, so I will just open the launcher for now. Now 192.168.1.1, we didn't set up any username or password in our ASA, so just go ahead and click OK. And the connection to this website is untrusted. Let's just move on, continue. Okay, so we don't have license for the ASAv. Click OK and click OK again. Now we have complete access to the ASDM. Okay, now just navigate through the menu. Home will have status indication, so we will have the general device information, host name, ASA version, we are using the ASDM version, the firewall mode, and the total flash memory we have, and license information is also provided. We don't have any license for now, but regardless, we have the option to do 3DS and AS up to 200 VLANs. Active standby failover can be done. We can have 2 SSL VPN peer and 750 VPN peers. So this is more than enough to accomplish our CCNA Security labs. We do also have virtual resources here. So we are using 2 virtual CPUs, and I have assigned 4 MB RAM for this virtual ASA. Okay, so these are just the general information on our device. We can also have the configuration menu, so that we have device setup, firewall, remote access VPN, site-to-site VPN, and device management can be achieved. We have also monitoring capabilities. We can monitor the interface we have. We can monitor the VPN. So all of this can be monitored. Okay. Now, for now, let's just go ahead and click on the wizard and click Startup Wizard. So we are going to do the configurations. So for now, we are going to modify the existing configuration. Click Next. The host name we are going to assign is CCNA S-ASA. Domain name will be CCNA Security.com. And then we are going to change the enable password or the privilege mode password to Cisco 12345. Cisco 12345. So this will be the privilege password we are going to use, and the domain name will be ccnasecurity.com. Okay, Once we have this, let's confirm this. Cisco 1, 2, 3, 4, 5. And click next. Now the third step is the interface settings. So we have the outside interface, G00 is used, and a security level of 0 is assigned, and we manually assigned IP address to 09.165.200.226, and subnet mask is also good. So this setting is fine for the external interface, and click next. And we also did two more assignments. We have the inside interface, like G01 interface is the inside interface with a security level of 100 and gigabit 02. The DMZ interface is 192.168.2.1 with security level of 70. So these are the three interfaces we have defined. Okay, and for these interfaces we are going to enable traffic between two or more interfaces with the same security level. Okay, and we can also allow traffic between two or more hosts connected to the same interface, and click next. Now we are going to set up a static route. Okay, so we will set up an IPv4 static default route. If you look at the GNS3 configuration for this ASA, if there is a packet with an unknown destination, the only exit we have is this next hop address, the 209.165.200.225 IP address. That's what we are going to assign now. So click add. So the interface we want is the outside interface. Okay. And for this outside interface, we are going to define an NE4 network, which, because our aim is to define a static default route, so unknown network should be simulated, and the gateway will be 209.165.200.225 and click OK. So now we have defined static default route and click next. Now we are going to enable the HCP server on the inside interface. The starting IP address will be 192.168.3.31 and ending IP address 192.168.1.39. And the DNS server, let's say 10.20.30.40 is being used. Okay, please make sure you do not enable this. Okay, we don't want auto configuration for the interface, and click next. Let's see. Oh, yeah, this is 192.168.131 to 139, and click next. Now we are going to use port address translation so that the IP address on the outside interface will be overloaded. Okay, and click next. Now we are going to give administrative access to the internal. This is what we gave already. HTTPS and ASDM access was given to the inside network. Now we are going to add SSH access. Okay, click add. We are going to give an SSH access to the internal network 192.168.1.0 with 255.255.255.0 and click OK. Now we are going to add SSH access to the outside network. 172.16.3.3. We want to give only for one host and click OK. So now we give SSH access and we enable HTTP server for HTTPS and ASDM access and click next. Here we don't have to do anything, we are going to move on. So for anonymous reporting we don't want to enable, so we do not enable smart call home and click next. This is what we have done so far. Okay, and finish. Now since we have assigned a privilege mode password, we didn't set up any username yet, but the privilege mode password Cisco 12345 should be used here and click OK. Now we have the basic device configuration done. Okay, so we have configured the administrative access to the ASA by enabling HTTPS ASDM access, SSH access to the internal network, and to one host to the outside network. Now let's verify if this is indeed true. So now we are going to open a web browser on PCB. So we have set up the HTTPS ASDM access to the inside network, SSH access to the inside network, and SSH access to the 172.16.3.3 outside host. So these configurations are now done. Okay, so we don't need to set up anything in here. So these are now done properly. Finish, and let's see if the configurations are done correctly. Okay, now in order to test this, we are going to try accessing an external website from PCB. So I'm going to open a web browser. I'm going to open Google Chrome and try to access the R1 router from HTTP only. Hit enter and it will ask us for the username and password. Admin01 is the username, admin01 pass is the password, and I was able to log into router R1. This verifies that the administrative access rule we have set up for the internal network is working. Okay, now let's test access to the external website. So I'm going to exit out of this. Now in the ASDM I'm going to go to tools and packet tracer. So now in this packet tracer I'm going to trace from the inside. Okay, I'm going to use TCP 192.168.1.3. this is the source. It is originating from port 1500 and I'm attempting to trace packets to a destination IP address of 209.165.200.25. So I'm trying to hit the router F00 interface and we want to check it with HTTP and start. Let's see if we have access to the external website from our internal network. As you can see, we have access to the external website from the internal network, so because the packet is permitted. Now let's clear this and attempt from outside. Our packets are originating 209.165.200.25 and we want to hit 209.165.200.26. Let's try, this is a telnet access. Source port is 1500 and start. Now from external to internal. So this traffic has to be blocked. Okay. So this is actually denied. Okay. So now the next task is to set up date and time. Click on configuration, device setup, clock. Just make sure you select the time zone you are in and just fix the date and click apply. Okay, so that will be for time setting. And then we are going to, we have already set up a static default route. So if we click on tools and ping and attempt to ping the 10.1.1.1 interface, ping should be successful. So this shows that our static default route is properly done. Okay, now let's see the route to the external network now. I'm going to open tools and trace route. Let's see the route to 172.16.3.3. If we trace the route to 172.16.3.3, our route is fine. Okay. Now we are going to set up a local user account. Close this. Click on configuration, device management, user account. We have already created admin01. So if I edit this user, you will have admin01. I have already put the password to admin01, password admin01 pass, privilege level 15. You set it up like this and click OK. So once we do that, under device management, click on users and AAA and click on AAA access. Under AAA access, make sure HTTP ASDM and SSH is chosen and click apply. Now let's test our SSH access. Okay, from PCB we are going to use PuTTY. I have PuTTY now. I'm going to SSH to the ASA 192.168.1.1. Open. Now login as admin01 pass. So now we are able to SSH from the internal host. Okay, we are able to SSH into the internal host. I'm going to exit out of this. Now let's try to SSH from the external host. Our external host is Windows 10 and I'm going to open PuTTY. 209.165.1.26 is the external interface. I'm going to SSH into it. Yes, login as admin01 pass. So this shows that I'm able to SSH into the ASA. Now we are going to modify the modular policy framework. So click on firewall, service policy rules. Okay, edit the global policy rule and click on rule actions and make sure ICMP is selected and click OK. So that should be fine. Now if we ping from PCB, to 10.1.1.1, ping has to be successful because we made changes on the modular policy framework so that ICMP will be monitored. So that makes this ping successful because the echo reply will not be dropped. Now we are going to configure the DMZ. Okay, under configuration, click on firewall and click on public servers. Under public servers, we have already set up the server. You can edit it. I'll just edit it, and the private interface will be DMZ, and the private IP address, you will just click add and put the 192.168.2.3 IP with name DMZ server, and then double click it. Click OK and click on the private services ellipsis and double click the ICMP echo reply, TCP FTP and TCP HTTP services and click OK, and put the public IP address 209.165.200.227, so that this will be the translated address, and click OK and click apply. That makes the DMZ service. And now once this DMZ is set up, we can verify the connectivity by pinging from outside. Let's ping from PCC now, from the Windows 10 machine. CMD, I'm going to ping 209.165.200.227. This is the translated address for the DMZ server, and as you can see, I was able to ping. Now from the internal network, I'm going to ping 192.168.2.3. I should be able to ping. Okay, so this ensures the DMZ is accessible, but trying to ping from the DMZ to the internal network should fail. Let's verify this. From the Windows 8 machine, I'm going to ping 192.168.1.3, and this ping will fail. Okay, because by default traffic from lower security level to higher security level will be blocked. Okay, so this ensures we have end-to-end connectivity and our ASA is properly configured. So now we have full connectivity of the network. Thank you for watching, and if you have any suggestions or any improvements you want to do on these videos, please let me know, and I'll see you in the next videos.